education. Today we'll be solving some of the hardest questions from the 9702 physics. These are 20 MCQs. I'll be trying my best to solve all of them. They are from the all variants of the 2024. So now let's begin. The first question is a model car travels at a constant velocity of 12 meters per second in a straight horizontal line. The input power to the engine of the car is 800 watt. The efficiency of the engine is 60%. What is the total horizontal force on the car? So first of all, to solve this problem, they have given us the input power and the velocity and the efficiency. So for the efficiency, we know that efficiency is equals to power output divided by power input and into 100. Now we know the efficiency, so we can divide it by 100, so it becomes 0.6 is equals to the power output. We don't know the power output, but we know the power input, so it becomes 800 watt. This will give us the power output will be 480 watt. So because we have to multiply 800 into 0.6, so it becomes 480 watt. Now we can use this formula, power is equals to force into velocity, because this is the force that is actually you can say this equation actually made for the force of the that is actually causing the acceleration, but this force can also be the resistive force. So we can apply the power. 480 is the output power because that is actually driving the car, and the rest will be, I think, wasted, the 40%. So 480 is equals to F. This is the resistive force. You can also write Fr into 12, which was the velocity. So this will give you the resistive force. Let's calculate this. 480 divided by 12, 40. So 40 Newton. So this means B is our answer. The second question says the graph shows the relationship between the stress and the strain for the three wires of the same linear dimensions but made from the different materials. So from different materials means they have different Young modulus. So now you can see for the P, it has less strain for the same stress. So you know the formula for the Young modulus. Young modulus equals to stress over strain. So now if you know that it is causing the same for the same stress, it has less strain, so the Young modulus will be higher. And for the Q, it has, you can say, it will have a less Young modulus because it has a more strain. So if the denominator is increased, the Young modulus will decrease. For example, if this is decreased, this will increase, and vice versa. If this decrease, this will increase. So now let's have a glance at the statements. The first one says the extension of the P is approximately twice that of the Q for the same stress. Now this is incorrect because you can see that the extension, which is the strain, it is approximately half that of the Q. So this will be wrong. The ratio of Young modulus for P to the Q is approximately 2. Now this is correct because you can see that the strain is half. So for example, if we place the strain as half in the denominator, this is gonna move to the numerator and the Young modulus will be 2 times that of the Q. So this will be correct. The third statement says for a strain less than 0.1, R obeys Hooke's law. So Hooke's law is obeyed because we know that the line is straight and it is linear. So it means the extension produced is directly proportional to the stress, or you can also say the force. So the third statement will also be correct. So 2 and 3 are the correct statements. So our answer will be C. Now our third question says a rectangular block of lead of density 1.13 into 10 power 4 kg meter cube has a sides of 12 cm, 15 cm and 10 cm. So they have actually given us the three lengths. These are the three sides, and now they are asking what is the maximum pressure of the block that it can exert when resting on the table. So now first of all, to solve this type of questions, what you actually have to do is that, for example, we know that pressure is actually equal to force upon area. Now you know that if you want to have the maximum pressure, you should have the least area. So now for the least area, you should select two lengths which will give you the minimum value. So I can clearly see that 12 and 10 will give me the minimum area and the highest pressure. So now we are decided with the area. So for the maximum pressure, this will be P max. We have to find, okay, now we do not have the force. So you know what is force? Force is mg. And what is m? M is density into volume and into g. This will be the statement for the force because they have given us the density. So 1.13 into 10 power 4, and we can calculate the volume by the three sides, so it will become 12 into 10 power minus 2 into 15 into 10 power minus 2 because it is in cm into 10 into 10 power minus 2 and into the gravity. So this will be divided by the area, which will be 12 into 10 power minus 2 into 10 into 10 power minus 2. So P max, or the maximum pressure, will be, now let's calculate, 1.13 into 10 power 4 into 12 into 10 power minus 2 into 15 into 10 power minus 2 into 10 into 10 power minus 2 and into 9.81, which is the gravity. This will be divided by 12 into 10 power minus 2 into 10 into 10 power minus 2. So we will get our answer as 166.27.95 pascals. So this will become 16.6 into 10 power 3 pascals. And if they ask you about the minimum pressure, then you have to keep the maximum area. So for this question we have D as our answer. Now let's move on. Now in this question they are telling us about the four forces act about a point P as shown. So the forces act in the same plane and produce no resultant moment about the point P. So P will actually be the, you can say the, they are actually considering it as the pivot. So what is the length xy? So now if you see that the length xy and the forces that are actually, you can say, moving it, that looks like a uh, like a like a torque of a couple. So what we will do is that first we have to find the horizontal component of this length. So what we can do is that first of all we will find this length. So these are actually the alternate angles. You can see these two lines are actually similar, so this angle will be equal to this angle. So now what we can do is that this line, this will become, and you can see this whole line actually, this will become what? This will become xy sine of 60 degree. And now you can just use one of the forces like the couple. So this will cause anti-clockwise movement and this one will cause clockwise movement. Now you know the length for the 6 Newton, it will become 6 into 10 and then equals to, we will have 5 into xy sine of 60. So now you can calculate this. 60 divided by 5 is actually 12, and this becomes xy sine of 60. So this becomes 60 divided by 5 is 12, so this will be divided by sine of 60 to get you the length of xy. So now you can calculate this. 12 divided by sine of 60. So this becomes 13.85 meter. So you can just round it off to two significant figures. It becomes 14 meter, or the option C. So this is how you have to solve this type of question where it is not perpendicular to the other forces, or you can say the line of action. Now the fifth question says a horizontal beam of vertically polarized light of amplitude A is incident normally on a polarizing filter. The transmission axis of the filter is at an angle of 50 degree to the vertical. What is the amplitude of the light in the beam after it passes through the filter? Now you have studied one of the most popular formula for this, and which is I naught cos square theta actually results in the new intensity, which is after passing through the polarizing filter. Now this is the formula for the intensity. Now for the amplitude we have the same like this. This is the resultant amplitude is equal to A cos of theta. Okay, no square and anything like that. So the resultant amplitude will be this, and the the incident amplitude is A, and then cos, and then the angle is 50. So now you can just calculate this new amplitude, and it will become cos 50, which is 0.64. So this will become 0.64 A. This will be your answer, and C is the correct option for this. Now for the sixth question, we have a progressive longitudinal sound wave moves through the air. The diagram shows the position of the particles in the air along the path of the wave at one instant. So point Q is at a distance x from the point P. Okay, so they have given you the distance between P and Q. So which graph shows the variation of displacement of the air particles with distance from P along the wave? So this is actually a very important question. So first of all, I would like to make you understand that for the mean position of the particles, for example, they are going no rarefaction or compression. You can see this is the rarefaction and this is the compression part. Sorry, this is not the compression part. I have just reversed both of them. Let me just remove this. So this is actually compression because the particles are coming close to each other, and at the P and the Q the rarefaction is occurring. So what happens is that this is actually, for example, the mean position of the particles. Okay, there is no rarefaction and compression at this instant. So what actually happens that, for example, if there is rarefaction, this moves from the mean position. It has a positive displacement. Okay, positive displacement, just remember this point. It has a positive displacement. It is moving more than it is at the mean position. And for example, if there is a compression, they come close to each other. They are coming close to each other. They are having a negative displacement. And for the mean particle, like the center particle, this and this, they don't move. They are stationary. The side particles, the other two, they only move. So you can see that at the P and at the Q we have the centermost particle. Okay, so this will not move. So we are gonna look for the option which have the displacement 0 initially. So A is actually fulfilling this, and B is also fulfilling this. And let's have a look at the C and D. So now you can see C is also fulfilling this, but D is showing some displacement, so we can just eliminate D at the first glance. Now let's just scrutinize between A, B and C with the further displacements. Now what happens when there is the compression? This particle don't move, and this will have a negative displacement. So the it will the line of the graph will move below the and into the negative axis. So now you can see this. First of all, it will be like this. Let me make the graph first. So first of all, I will make a graph here like this. For example, if this is the graph, for example, this is the graph. So first of all, it is having no movement, it is a stationary. Then it is having a positive displacement because some of the particles are away. Then it will come to zero because there is a particle at the compression, the centermost, which is having no displacement. And then it will have a negative displacement because of its moving away from moving less than the mean displacement. And then it will come again to zero when there is rarefaction again. So there will be not positive displacement for all the points and not negative displacement for all the points. You can see here we have the positive, then it is coming to zero, and then here we have the negative displacement, and then again it comes to zero, and in the same manner it will move again as positive. So you can see C actually is fully filling this point. This is point of the you can say the mid point or mid particle of compression. So this actually fulfills the you can say the movement they have given us between P and Q. Now the other question says an electromagnetic wave is diffracted as it passes through a single slit. The width of the slit is larger than the wavelength of the wave. Which change will decrease the amount of diffraction of wave? So I have told you that diffraction is directly proportional to the wavelength, and the max diffraction occurs when the wavelength and the slit size are approximately the same, and diffraction is inversely proportional to the slit size. Now let's have a glance at the options they have given us. So which change will decrease the amount of diffraction? So if we are looking for the decrease in the amount of diffraction, we are actually looking for the we will decrease the wavelength or we can increase the slit size. Now they have given us decrease the frequency of the wave. Okay, so actually you can say they sometimes give you an indirect relationship between the asked option and the desired result. So for example, if we look at it, that what is actually frequency? Frequency is inversely proportional to the wavelength. If they are decreasing the frequency, they are increasing the wavelength. So we do not want the wavelength to be increased, we want it to be decreased. So the option A will be incorrect. Then they are saying decrease the time period of the wave. Now we know that frequency is 1 over time period. If we are decreasing the time period, we are increasing the frequency, and now the relationship between the frequency is 1 over wavelength. So if we are increasing the frequency, we are decreasing the wavelength. So this can be the correct option. Then they are asking us decrease the width of the slit. So now if we are going to reduce the number of diffraction, we are gonna increase the width of the slit, not we are gonna not gonna decrease the width of the slit. So this will be incorrect because this will increase the diffraction. Then D says increase the wavelength of the wave. We want the wavelength to be decreased, not increased, so this will also be wrong. So B will be the correct option here. So this is how you should know that how you have to deduct the relationship between the different variables. So now let's move on. They're telling us an electric current of 12 amps is in a wire of length 0.35 meter. The average drift speed of the free electrons charge carriers in the wire is 5 into 10 power minus 4 meter per second. How many free electrons? They are not asking you about the charges, they are asking you about the electrons. And we know that one elementary, or you can say one electron, is actually equal to 1.66 into 10 power minus 19 coulombs. So now let's solve this question. So they have given you, let's try to solve this. Okay, so what can we do actually? If we just try to use this formula, I is equals to NEAV, they have not given you the number of charges, nor they have given you the any you can say the cross sectional area that you can use. So what we are going to be doing is that we are just gonna simply take out the time period. How we are going to be calculating the time period? We know that speed is actually equal to distance divided by time. Now we can take out the time is equal to distance divided by speed. So they have given you this distance, which is 0.35. The speed is gonna be 5 into 10 power minus 4. So let's calculate the time. 0.35 divided by 5 into 10 power minus 4. This becomes 700, and this is gonna be in seconds. Now you know the formula for the current, which is charges per second. Now multiply, if you want the charges, you can just multiply the current into time. So current is 12 into 700. This will give you about 8400 coulombs. Okay, this is 8400 coulombs. Now we know that one electron is actually equal to 1.66 into 10 power minus 19 coulombs. So how much will be 8400 coulombs? You can just cross multiply and you will get the number of electrons. So this will be 8400 divided by 1.66 into 10 power minus 19, and you will get about 5.3 into 10 power 22. So B will be the answer for your question. Now they are telling us a lead pellet is shot into vertically upwards into a clay block that is stationary. So stationary means it has no movement at the moment of impact, but it is able to rise freely after impact. Okay, so the mass of the pellet is 5 grams. They have given you the mass in grams, so make sure you convert into kilograms. And then the mass of the clay block is 95 grams. The pellet hits the block with an initial vertical velocity of 200 meter per second. It embeds itself. Embeds itself means they are just you can say combined together and in the block and does not emerge, so it remains in the block actually. So how high above the its initial position will the block rise? So now how are we gonna do this? This question is just trying to test momentum and the kinematics at the same time. So first of all we will use the momentum. We know that initially the pellet is at the movement, so it will be 5 into 10 power minus 3 because it is in grams, and we have the speed which is 200. The This is going to be the block, but it is stationary, and this will be actually equal to the combined mass because it embeds. So 100 into 10 power minus 3 into v. So now we are going to calculate this. This is going to become 0.1 v, and let's calculate the other side. So it will become 5 into 10 power minus 3 into 200. This becomes 1. So this becomes 1. So 0.1 divided 1 divided by 0.1, it becomes 10 meter per second. So this is actually the combined speed of the block and the pallet. Now we are going to use the kinematics. 2as is equals to v square minus the u square. We know when at the maximum height the speed will become 0, and then it is going to move downwards after it. So it is moving against the gravity, minus 9.81. Then do we have the distance or the height? No, we are going to find it. So this is the displacement. And do we have the final speed? It is going to be 0 because it is the maximum height, and we know the initial speed, which is 10 meter per second. So now let's calculate this. This will become 5.091 meter per second. So the closest option for your height is 5.1 meter. So this is not meter per second, only meter. Okay, so A will be your option for this question. Now, a stationary sound wave is set up between a loudspeaker and a wall. The microphone is connected to the cathode ray oscilloscope (CRO) and is moved along a line directly between the loudspeaker and the wall. The amplitude of the trace on the CRO rises to a maximum at position X. So maximum actually means, and it is a stationary sound wave. So this means that it is at the maximum. So this means it is an anti-node, and it falls to minimum, and then minimum means it is a node, and then rises once again to maximum. So once again it is an anti-node at a position Y. So this is X, this is Y, and there is a node between it. So you know that the distance between successive antinode is half lambda. So successive antinode have a distance of half lambda, and the distance between X and Y is actually 33 cm. So you are gonna convert it to meter. This is gonna become -2. So now you are just gonna um, take out the wavelength using this. So one wavelength is equals to X. So now X will give you the value for the wavelength. Let us just calculate this. So this becomes, this comes out to be 1.515. Actually I've done mistake, I have just reversed it. So it is going to actually become, let me just recalculate this. Okay, so just give me a minute. So this is going to become 33 in 10 power minus 2 and divided by the half lambda. So this is going to become 0.66 meter. Now this is the wavelength. Now what are we going to be doing is that we are going to find out the frequency. V is equals to f lambda. This is the most famous equation you should know, and 330 divided by the lambda, 0.66 is equal to the frequency. The frequency is 330 divided by 0.66. This is 500. So frequency is 500 hertz. You can just calculate the time period. So time period will be 1 over frequency. So time period will be 1 over frequency. 1 over 500 actually becomes 0.002, or you can say 2 into 10 power minus 3 second, or you can also say 2 millisecond. Now what you have to do in these, how you have to choose between these graphs is that you have to calculate the time period for each. Okay, the time period for one wave on each of these. So you can see that one wave on this first graph is taking about 1 2 3 4 5 6 7 8. So 8 small boxes. So 8 into 0.5 millisecond, they have given in millisecond, so it will become 4 millisecond. But we have the time period 2 milliseconds, so this will be wrong option. Let's check for the B. It is for one wavelength 1 2 3 4. So 4 into 0.5 becomes 2 millisecond. So now this actually matches the option, so B will be the answer. Let's have a look at the other two options. So this is one wave and this is about 6 small boxes, so 6 into 0.5. And one thing I want to tell you that they have given you the unit actually for 1 cm, which is the one small box. So 6 into 0.5 becomes 3 millisecond. So this is also not the option. And for this is only two boxes, so 2 into 0.5 becomes 1 millisecond. So this will also be wrong. So B will be the answer. Let's move on. This question says a block is moving along a horizontal frictionless surface. A constant force F and a constant resistive force of 5 Newton act on the block as it is moving in the direction of the force F as shown. The graph shows the variation with the time of momentum of the graph of the block. What is the magnitude of the force F? So one of the most you can say the pinpoint of this question is the resistive force, because what most of the students will actually do is that they will just calculate the change in momentum. Force is equals to change in momentum and divided by the time. They have given you the time, I think. Let me just check. Yes, they have actually given you the graph. So force, then they have given you the mass. Let me check it. So it is let me check. Okay, so I think this is okay. They have given you actually the momentum, so no need for the mass. This is the final momentum. This is the initial momentum. Be careful. This is not 0. This is 1.5. So final minus initial. 1.5 minus 2.7. This will be negative because it is the momentum is decreasing. So this will become 0.4. The answer will be 5 Newton. Not 5. I think it is. Let me just check. Okay. So it is not 5. Let me just recalculate it. 1.5 minus 2.7. 1.5 minus 2.7 divided by 0.4. This is minus 3. Minus 3. And now you know the resistive force. It will become 5 minus 3. And this will give you the resultant force, which is 2 Newton. Okay, so A will be the answer for this question. Now this is very interesting question. An object is held in equilibrium by three forces. The forces all act in the same plane. The diagram shows two of the forces that act on the object. Now they have shown you the 17 Newton force and the 43 Newton force. So now they have actually told you one of the most, you can say, you can just hit the answer directly using this one point. This is equilibrium, and we know that the vector triangle always forms like the it is, you can say, a triangle, the equilibrium triangle, which is always like this. Let me just draw it. So it is, so this is how an equilibrium triangle looks like. It is actually a, a type of closed loop, like the tip of the first vector matches the tail of the other vector, and in the same way the second vector tip matches the tail of the other vector. So it is actually form, you can say it is forming a closed loop. So in this same manner, what we are gonna do is that we are gonna make the same type of triangle here. So you can just make it like this. This is the first. Okay, this is the first, and then you are gonna ensure that the tip of the first matches the tail of the second. So this is gonna become like this. Okay, you have to make it to scale. So this is like this. So now if it is like this, and the other one is like this. You can see the tip of the first matches the tail of the second, and then the tail of the second should match the tip of the second should match the tail of the third one. So without any calculation you can just reach your answer like this. So it will be in this direction, and you can see that in all of the options only B matches the correct answer. So B will be the option. As it is equilibrium, so equilibrium always forms an equilibrium triangle. And you can also check the other options, they do not form the equilibrium triangle like this. Let's move on. The diagram shows the arrangement of the atoms in a particular crystal. Each atom is at the corner of a cube, so the mass of each atom is 3.5 into 10 power minus 25 kg. The density of the crystal is 9.2 into 10 power 3 kg meter cube. What is the shortest distance between the centers of the two adjacent atoms? So they are actually asking you about this distance, the distance between two atoms, the center of the two atoms. So now most of you will not be able to solve this question because um, most of the teachers do not teach this formula, or because this does not come always, and I've only seen this one question about this in the 2 to 3 years. So let me just show you how to do this type of question. So whenever they ask you about the distance between the two adjacent atoms, what you have to do is that first of all you have to take out the volume. So volume is the first objective. So take out the volume first. They have given you the density and the mass. So density is equals to mass divided by volume. Volume is equals to mass divided by density. So it is gonna become 3.5 into 10 power minus 25 kg and divided by the density, which is 9.2 into 10 power 3. This will give you the volume. Let's find it out. So 3.5 into 10 power minus 25 divided by 9.2 into 10 power 3. This gives you the value 3.8 into 10 power minus 29. Now when you have found the volume, what you have to do is that you have to take cube root of volume. This will give you the distance between two atoms. So you can say under root cube root 3.8 into 10 power minus 29. This will give you the value 3.36 into 10 power minus 10. So you can see C is the correct option here. So this is how you do this type of question, because this does rarely comes in, but you will in case if you do not know the formula, you are gonna uh, end up losing 1 mark. This is just an easy question, but most of the people do not know the formula for this. Let's find out the answer for the next question, which is a wire is fixed at one end and is extended by the force F1 acting on the other end. This causes the wire to have an elastic potential energy of 0.15 joule. So do you remember the formula for the elastic potential energy? It is half Fx. Now they have only given you the EPE, elastic potential energy, and the force F1, okay, not any other thing. So the force applied to the wire is now changed by the force F2. This causes the wire to have a new elastic potential energy of 0.6 joule. So again they have given you the other force, and this is EPE. The wire obeys Hooke law. So actually they are just ensuring that you can use these formulas, the formula for the Hooke's law, like F is equals to Ke, and the formula for the elastic potential energy. So what is the relationship between F1 and F2? So one thing I want to just reinsure and confirm here is that you have to just do not ignore the extension here, okay? Because if there is an F1 and F2, there are two type of different forces. They are for sure gonna cause a different change in length. and that different change in length is responsible for the different elastic potential energy. But how are we going to find out the extension? So you know that F is equals to Ke, the K is the constant, and we also know that K will be equal to, the extension will be equal to F over K. So this will be equal to the extension. Now what we can do, we can just place the F over K in place of the X, or you can say the extension. So it will become half F into F over K. This becomes half F square over K, and this is equal to EPE. Now you are gonna solve this using the you can say the proportion method, or you can say the relationship between the EPE and the force. So EPE is directly proportional to the square of force. So in case if this is 0.6 joule is caused by F1, by F2 actually, this is gonna be squared and then divided by, this is 0.15 joule, and this is caused by the F1 square. Now you just need to solve this out. So to solve this out, you have to under root both of the side. This will become, let me just find out the answer. So this will become 1 by 2 equals to F2 over F1. So now you can just cross multiply. So F1, actually this is 2. I have just reciprocated it by mistake. So this is 2 and this is 1. You can just multiply this. 2F1 is equals to F2. So this is the relationship that this equation will actually give you. So this will be the answer for this question, and you can see that C is the correct option here. Now let's move on to the other question. It says a student investigates the polarization of the microwaves. The microwaves from the transmitter are vertically polarized, so they have told you that it is vertically polarized. A metal grill acts as a polarizing filter when placed between the microwave transmitter and the receiver. The reading on the voltmeter is proportional to the intensity of the microwave transmitted through the grills. This is the one of the important point in the questions. Now when the transmission axis of the grill is vertical, the voltmeter reads 3.5 volt. So this is the unchanged voltage, or you can say it is, you can say the incident, you can say the intensity or the voltage before there is any change. The grill is then rotated through an angle theta. The voltmeter now reads 2.2 volt. So what was the point of saying that the voltmeter is, the reading of the voltmeter is directly proportional to the intensity? They actually want you that you can take this voltage as the intensity. So this will become 3.50 I, and this is the unchanged intensity, the intensity that is incident, okay, and this is going to be the changed intensity, which is 2.20 I. Now we know the formula for the Malus law, which is I naught is equals to I cos square theta. Now we know that the transmitted intensity is 2.2 I, and the, you can say the initial intensity is 3.5 I, and cos square theta, you can just cut out the I and divide the 2.2 by 3.5. This is gonna become cos square theta. Just under root both of the sides to eliminate the square. So this is gonna become, I'm doing the working here, so this is gonna become cos theta is equals to under root 2.2 divided by 3.5. It comes out as 0.7928. Now you can find out the theta, cos inverse of 0.7928, and the theta is gonna become 37.5 degree. So A is going to be the answer for this question. Now the next question says the resistance of the metal cube is measured by placing it between two parallel plates as shown. The cube has a volume V and it is made of material with a resistivity rho. The connection to the cube have negligible resistance. Which expression gives the electrical resistance of the metal cube between X and Y? So now we know that for the resistivity we have one formula. R is equals to rho L divided by A. Now have they given you the electrical resistance? No, they are asking about it, and they are also asking you about the expression for it. So you know that rho is given and this is L. Okay, so what is actually area? Area is L into L, or you can say length into L. So now how are we going to be finding out the, you can say, the electrical resistance relationship? Now what can we do is that we can just introduce one variable here which will actually become, we can just you can say cross these out, the L and the L. So this actually becomes what? Rho over L. Now what is the volume? You know volume is L into L into L, or you can also say it is L cube. Now if I am gonna take one of the part, only one of the length, what it is gonna become? It is gonna become one third part of this volume. This is the main concept in this question. And if I'm gonna take the area, area is actually the two-third part because it is L into L, and 3 by 3 of the parts of the volume is actually the volume itself. So we have only one length here, so can we write it as this? V 1 by 3 part of the volume. So this is what is the main concept here, and C will be the answer for this question. Now question number 19 says a spring of spring constant 30 Newton per meter is suspended vertically from its top. The spring obeys Hooke's law. Initially the spring is not compressed and not stretched. A mass of 0.5 kg is attached to the bottom of the spring. The mass is released from rest and it falls. So now the main point in this question is not compressed and not stretched. Whenever they use the keyword like this, it means this type of the material have 2x the extension. So a mass of the 0.5 kg is attached to the bottom of the spring. The mass is released from the rest and falls. Frictional effects are negligible. In the motion that follows, what is the maximum? And you can see it is asking about the maximum extension. So we know that for the formula is F is equals to Ke. Now the spring constant is 30 Newton per meter, but for the force we have to multiply 0.5 into 9.81 because force is equals to mg, and then we have the 30, and then we have the extension. You can also say x, or you can also write e. Now x will be equal to 0.5 into 9.81 divided by the 30. So this will become 0.5 into 9.81 and divided by 30. So this is going to become 0.1635. But we are not done yet. I have told you that for not compressed and not stretched material, you can see that whenever we try to uh, blow air in a balloon, we first of all stretch it because it actually increases its elasticity. So for the non-stretched and non-compressed material, the extension is going to become 2x. So it is going to become 2 into 0.1635, and it is going to become 0.33 meter. So D will be the answer for this question. So this is actually a very tricky question because most of the students do not know this point that the it is the extension is 2x for the non-compressed and not non-stretched material. Now we have this last question, which is waves P and Q have the same amplitude. The waves meet in phase at the point X and interfere to give a resultant wave with the intensity I. Now they are given you two waves, okay? They have the same amplitude. Let's consider it as A. Now they meet in phase at point X and interfere to give a resultant wave. So you know that the interfering waves, their amplitude actually produces a resultant, and A plus A will become 2A. This will give this resultant amplitude, and its intensity is I. Okay, then they are saying the amplitude of the wave P, only P, is doubled, so it will become 2A. What is the new intensity of the resultant wave? And they are asking you about the resultant wave. Okay, so now you know that this is 2A plus the A of the Q. This is going to become 3A. Now what is going to be the new intensity? We know that the intensity is directly proportional to the square of the amplitude, so this is going to become squared. Now let's do it here. So it will become I equals to 2A and divided by the 3A. This is going to become whole square, and this is going to become xi. So now let's multiply this by, this is going to become 4A divided by 9A and I over xi. So let's multiply this. This is going to multiply it here and the 4 here. So this is going to become 9 by 4. So x is actually going to become 9 by 4, which is 2.25. So we have the nearest answer, 2.3i. So C will be the answer for this question. And now we have completed this worksheet. I'll be attaching this worksheet in the description down below. So make sure you subscribe this channel for more questions like this and for more past paper solutions, and share it with anyone who you think it will help. I'll be meeting you in another video. Till then, goodbye.